Alright, so now let's focus on getting the domain of graphs that have jump discontinuities. And there are two very popular ways of doing it. I'm only going to show you one way. So here's the strategy. And again, this only works for pieces that have a jump discontinuity. So here, we're going to pretend that this part is continuous with that part. So we're focusing on domain. So we're going to pretend that we have this stick that kind of connects both pieces. And now we're going to just go about getting the domain like we've been doing up to this point. So I want to get the lower bound and I want to get the upper bound. So here we can see that the lower bound is going to be here at -6 with a solid line because of that closed dot. So here I have -6, and then the upper bound, it looks like it's going to be here at +5, again with a solid line due to that closed dot. So if we want to express the domain using interval notation, we're going to use the endpoints, so -6, +5, and we're going to use brackets on both ends because they both had closed circles. We can apply the same ideas for graphs that tend to infinity. So for this problem here, again, we notice that we have a jump discontinuity. So we're going to pretend that these two pieces are connected by a continuous stick here. So we pretend that they're connected, and now we can get the domain here. So the domain, again, we're bounding from left to right with the x values. So on the left hand side, our eyes intuitively tell us that the graph ends right here. And that the graph begins right there and that the graph ends right here. But again, since we know how to read these mathematical statements, the implications are that the graph keeps on extending beyond this point, and this graph keeps on extending beyond this point here, and it's never going to stop. So here we can see that as this graph keeps extending to the right, the x values keep getting larger and larger as the graph keeps on extending. So here this is going to tend to positive infinity, and then on the other hand, as this graph keeps extending to the left, these x values keep getting smaller to the point of approaching negative infinity. So here the lower bound is negative infinity, the upper bound is positive infinity. So domain is from negative infinity to positive infinity. Or you can say that x is the element of all real numbers.